I made up a turn part for assignment 9, pretty much a tapered through bore, outside diameter 2.75. First step is 2 inch, the 2 1/4 to the O-ring, and the O-ring is just for reference. Pretty much we're going to do the facing operation, center drill, drill through, then start boring out the internal geometry, and then last will be the O-ring groove. So two things we need to be aware of is we draw the geometry in the normal coordinate system XY, and let's go ahead and generate the first part. And I showed you the offset lines and being able to generate that rectangle, treat it as a different level, and then trace over top of it at the end of the last video. I still lean towards doing the point coordinates, or at least that makes more sense to me. So one of the things to be aware of is that once we activate the lathe, then the coordinate systems shift to a D for diameter and the Z direction. So to contrast those, we're going to start at 0 and let's see, 2 inches for the diameter, 1 inch in Y. And then 0, our OD was 2.75 divided by 2. So that gets us to the start. And we would go 1.375 comma minus 3. Oh, got those reversed. Alright, so in point, we'll try minus 3 comma 1.375, and then our endpoint would be minus 3, and we have a 1.125 for a bushing. I didn't call out the sleeve bushing, but it has a press fit, so 1.125 divided by 2. Okay, so we'll go ahead and accept that. Now in contrast, if we go over to the machine, notice that we're in the top XY, go over to the machine and we pick the default lathe, that the coordinate system shifts to the diameter and the Z direction. So all of a sudden our coordinates are changed. Anything that are, well, translated. Anything that we would put in, we now kind of have to reverse. Alright, so program, assign tool number sequentially, worn 1 and 1. Going to select for aluminum. Oh, I can go to lathe library, they should be pretty much the same, but okay. And I still have to create all my internal geometry, but I have enough of the geometry created to get a good start. Alright, so 2.75, we're going to increase some distance. Position along the axis moves the stock out some distance. And then position 2.75 and Z location for the jaws minus 4. I'm going to go ahead and accept that. Alright, so if I go back into the wireframe and start with the line, I'm putting in the D value first, and so we're going to be at 2 inches on the diameter and 0 on Z. So that shows me my starting point. And we'll stay at 2 inches minus 0.65. Okay, go to the end point, and then we're tapering down to the 1.125. And it is back minus 2.5 inches. Okay, and then we can just connect those two endpoints. All right, my next for the O-ring groove, then we'll start at 2 inches on the diameter, minus 0.125 in Z. All right, and then we'll be at the OD of the O-ring, 2.25, and it'll stay at minus 0.125. Pick up the next point, 2.25 minus 0.275. And apparently I got the snap on. All right, so we're back to 2 inches on the diameter, minus 0.275. All right, I'm not worried about trimming that out, because that's going to be a separate operation. I'm not going to have the boring bar try to get into that geometry. So let's see, under view. Well, we're not snapping to the grid, so I'm not sure what it was jumping to. Okay, well, we have our geometry created. So we're back over into the to the machine and over to the turning. And with most all of our turning operations, we're going to face first, and that's going to establish our Z level. So tool 1 can stay with the 80 degree. Feed rate will drop down to 5 thousandths inch per revolution with a maximum of 2000 RPM. And constant surface speed. And then face parameters, entry amount, basically can stay with the defaults, 10 thousandths, overcut, retract, and stock to leave is 0. Okay, so it comes in, goes out, does the retract. We'll go ahead and include the center drill. So in our drilling operation, so spot drill, there we have a 1/2 inch center drill. Going to stay with the max spindle speed of 2000 RPM, 10 thousandths inch per revolution. Set the constant to spindle speed, or RPM, to 1000. So simple drill, no peck. In general, I want a 1/2 inch. I'm going to be close to a 1/2 inch depth to generate a 1/2 inch diameter with a center drill. Okay, drill point is at 0, 0, clearance 0.25, and retract to 0.1. And with those values, should be able to just do the straight plunge. Going back into drill, let's go ahead and look for a 1 inch. So 1 inch diameter, and we can look at the tool geometry, tools, holders, parameters. All right, so this is where everything originates from. This is going to be a pretty large drill without a pilot hole, and even though we have 1.25 or maybe a 1.125 drill, since this is going to be for a bushing, I am going to want to finish bore to that geometry. So spindle speed set at 200 RPM, 2 thousandths, and simple drill, no peck. We're going to change that to be a peck. And first peck can be 50 thousandths, and each subsequent peck 50 thousandths. And we'll give it just a little bit of clearance. Depth, we know we're going to 3 inches. So Let's go 3.5 inches and we'll see what that gives for clearance. I'd rather overrun a little bit. And then if this situation where we're going to have enough through bore to have a long piece of stock to bring this out, then we would not necessarily need the center drill with the remaining drill point at that end, and no custom parameters. Right, so that gets us into our geometry, overruns it just enough. We may decide to pull that back again because of the drill point and where we end up with how many of these we're going to run. Alright, lathe tool pass, we're going to contour rough, and you see why we left the line in place. So that gives me my position. We need a boring bar and we're looking for minimum diameters. Alright, so going 3 inches deep, let's go for the minimum 0.75 diameter. 1 inch is pretty snug. So let's give ourselves a little bit of room to maneuver. Feed rate 5 thousandths, constant surface feed at 200. And then the roughing parameters, stock to leave in X, let's bring that down to 5 thousandths. 5 thousandths, minimum cut could be 10 thousandths, minimum error. And entry amount, exit amount, we want to overrun that just a little bit, but let's check the lead in, lead out. So I haven't had good luck with the entry vector and exit vector on the ID geometry. So I'm going to extend the lead in just by 20 thousandths and extend the exit. Alright, and we're going to see what that gives us. Alright, so entry and exit amount, that should be taken care of in the lead in, and shows a collision. So yes, I want to save the operation. So I'll give it just a little bit more. Constant offset, well, 100 thousandths on the constant offset, that's for the material. So let's drop that down, and then we'll regenerate the toolpath. Alright, so I have a little bit more lead in. At the tail end, it's going to overrun some amount that when we go in to finish, I can at least get past that point. The other consideration is when we go to do the grooving tool and part this off, if I want this to go into the groove as opposed to pecking through, once it hits that 20 thousandths, that's pretty much going to jump off. So yeah, we'll have to see what it does with the machine for that run. Alright, so let's turn off the display. We're going to go back into the lathe tools, and this is going to be a finish pass. Pick up our chain. We're going to stay with the 3/4 inch, 2000 max spindle speed, 200 surface feet per minute feed rate for a finish. Let's go down to 2 thousandths. Alright, I'm pretty much jumping over these because there's not anything in miscellaneous values that I'm concerned with. Letting the stock update is fine. Any canned text that we would want to put in after the fact, we could put in after those operations. So finish parameters, finish step over, number of finish passes, stock to leave 0, stock to leave 0. So if we wanted spring passes, we could put those in. And I'm going to go back to my extend and lead out to be 10 thousandths on the finish. And we'll see what that looks like. Alright, so geometry comes in. And that gets us ready for the grooving tool. Alright, so lathe tools. going into the groove. I'm going to go ahead and tell it to do 3 lines. And we'll start, go to the next, go to the next. Less than 3 lines changed. Interesting. Oh, select the last entity, chain groove rectangle. Alright, so always read the tooltips. Alright, so feed rate of 2.5, we're going to drop that down to 1 thou. Finish feed rate of 0.5 thou. That's pretty good. Good size diameter. Spindle speed 200. Finish speed 200. Max 2000. We need to pick an ID groove tool, and we'll go with an 1/8 inch. So width 0.125. Okay, so groove shape, stock for outer boundary, no radiuses, no extra internals. We're going to rough bidirectional alternating, so it'll go in the center and then it'll step to the outsides. Percentage, stock to leave in X, 5 thousandths and 5 thousandths. Feed rate on the retraction. Plunge feed rate 2 thousandths, that's fine. And then the finish parameters, 1 finish pass, step over amount, no stock to leave, no stock to leave. Really stay with the defaults. Alright, so basically we touch off on the leading edge, and this is calculating for the leading edge of step in, step over, come in, and come back out. So basically on that tooltip. Alright, go back to the fit. And let's see, last one is to go, we're going to stay with the OD stock. And I want, as far as the grooving tool, 1/4 inch, let's stay with the 1/8 inch. Max spindle speed of, considering the grooving tool is going to be one a chatter, 1,000 at the most. Since it's at 1 inch, it shouldn't get there, but would rather limit it. Cutoff parameters, entry amount of 100 thousandths, retract to the radius and incremental value, 100 thousandths. Alright, and then somewhere in here, X tangent point, back face of stock at 0, no corner geometry. Now let's check the lead in, lead out. Gives us the direction vectors 90 and 90, so that's okay. And then I do want it to peck, so peck depth, we'll go with 30 thousandths. Okay, see what that looks like. Right, so again, touching off on the leading edge, pecking through, parts the tool, and then we're pretty much ready to run one of the simulations. Alright, so let's save this. And we'll go with the back plot first. Oh. And make sure everything's selected. Okay, so facing goes with the center drill, the drill. You can see each of the boring operation. And then the finish pass, grooving tool, and part. Alright, in contrast, when we go over to the verify, Alright, we're looking at this as solid. Okay. And that'll give us our preview of the stock. Everything else needs to take place at the machine with the cutting conditions.